Imagine opening your inbox to a security alert. A secret scanner has found your AWS access key sitting in your Git history, and it is live. This is not a hypothetical. It happens to experienced engineers every week. The moment that key exists as a static string, it is one accidental commit, one verbose logline, one shared terminal session away from permanent exposure. OIDC eliminates this entire class of problem by ensuring that long-lived AWS credentials never exist in your pipeline at all. By the end of this chapter, your deploys will carry no stored secrets, only short-lived tokens that AWS issues on demand and that expire automatically. AWS access keys are a deceptively simple solution to a hard problem, and their simplicity is exactly what makes them dangerous. Unlike a password tied to a human login session, an access key never expires on its own. You generate it once, paste it into GitHub secrets, and it sits there, fully valid, potentially for years. The attack surface is wide, verbose CI logs that print environment variables, a workflow that echoes its environment, a transient debug step someone forgot to remove, or a fork that inherits secrets through an improperly scoped pull request trigger. Every static key is a liability that compounds over time, and most teams never rotate them until after an incident. OIDC replaces the static key with a cryptographically verified, time-limited token, one that cannot outlive the workflow run that created it. OpenID Connect is a federated identity protocol built on top of OAuth 2.0, and it solves a fundamental question: how does one system prove to another who it is, without sharing a password? The answer is a signed JSON web token, issued by a trusted identity provider and cryptographically verifiable by the relying party. GitHub acts as that identity provider for every workflow run. When your job executes, GitHub mints a JWT that describes exactly what is running: the repository name, the branch or tag, the commit SHA, and optionally the deployment environment. AWS receives the token, verifies GitHub's signature using the registered OIDC provider, reads those claims, and decides whether to issue temporary credentials. No shared secret ever changes hands, only a signed assertion of identity. The entire exchange happens in 4 steps, and the configure-aws-credentials action handles it automatically. First, your workflow job starts on the GitHub runner. Second, the runner requests a signed JWT from GitHub's OIDC token endpoint. This is only possible because the workflow declares the ID token write permission. Third, the action sends the JWT to AWS Security Token Service using the Assume Role with Web Identity API call. AWS fetches GitHub's public keys, verifies the token signature, evaluates the trust policy conditions, and, if everything matches, returns a set of temporary credentials. Fourth, those credentials are exported as environment variables for the rest of the job. They carry a 1-hour expiry built in, and when the job ends, they are simply gone. Before your workflow can use OIDC, AWS needs to know that GitHub is a trusted identity provider. You register this once per AWS account in the IAM console. Navigate to Identity Providers, choose OpenID Connect as the provider type, and enter the GitHub OIDC provider URL along with the audience value of sts.amazonaws.com. AWS will fetch and store GitHub's public key thumbprint, which it uses to verify future token signatures. Once the provider is registered, you create an IAM role with the Web Identity Trusted Entity type, selecting the GitHub provider. At this point, AWS generates a default trust policy for you, but in the next slide you will see why the default is not enough and must be hardened with a condition. The IAM trust policy is the gatekeeper that controls which external identities can assume your role, and getting it wrong is one of the most common security mistakes with OIDC. Without a condition block, any GitHub repository in the world could present a valid GitHub OIDC token and assume your role, because the token itself would be cryptographically valid, just from a different repo. The fix is the string-like condition on the subclaim, which encodes the repository name. By restricting it to your organization and repository, you ensure that only workflow runs originating from your specific repo can proceed. The audience condition using string equals additionally validates that the token was requested for AWS specifically, not for some other service that also accepts GitHub OIDC tokens. On the GitHub Actions side, 2 things unlock OIDC authentication. The first is the permissions block. You must declare ID token right at either the workflow or job level. GitHub locks this capability by default. A workflow that omits this permission will fail with an error when the runner attempts to fetch the OIDC token, even if the IAM role is perfectly configured. The second piece is the configure-aws-credentials action from AWS. You point it at your role ARN and specify the AWS region. The action then performs the entire OIDC exchange, requesting the JWT, calling STS, receiving the temporary credentials, and exports them as the standard AWS environment variables that the CLI and all AWS SDKs automatically pick up for the remainder of the job. This is the full workflow file, everything you need to deploy a static site to S3 with no stored credentials. The permissions block at the top grants the two rights the job needs: ID token right for the OIDC exchange, and contents read so the checkout action can clone the repository. The configure AWS credentials step accepts the role ARN and region, performing the token exchange invisibly. After that, the AWS CLI is already authenticated. The sync command simply uploads changed files from the dist directory to the S3 bucket and removes files that no longer exist locally. Notice that the only non-default value identifying AWS is the role ARN, and that ARN is not a secret. The IAM trust policy ensures only this repository's workflows can use it. The contrast between key-based and OIDC-based authentication is stark when you look at them side by side. The old approach requires two GitHub secrets, the access key ID and the secret access key, that must be created, stored, rotated, and protected for as long as the pipeline exists. Any step in the workflow can read those environment variables. If a dependency in your build script logs the environment, you have a leak. With OIDC, neither of those secrets exists anywhere. The role ARN in the workflow file identifies which AWS role to assume, but knowing the ARN gives an attacker nothing. They still need a valid GitHub OIDC token from your repository to proceed. The credentials that emerge from the exchange live only in memory for the duration of the job and cannot be recovered afterward. GitHub's OIDC token encodes rich context about the workflow run in its subject claim, and you can use every part of that context as a condition in your IAM trust policy. The simplest restriction locks the role to a single branch, useful for production deployments that should only happen from main. A wildcard pattern using string-like allows any branch within a specific repository while still blocking every other organization. The most powerful restriction combines the repository name with the GitHub environment name, which we will explore on the next slide. Understanding the exact format of the subject claim is essential. It is case-sensitive, it uses forward slashes as separators, and the structure changes depending on what triggered the workflow. A branch push, a pull request, or a tag release each produce a different subject value. GitHub environments provide an approval gate and deployment context for production workflows, and they integrate directly with OIDC for defense in-depth security. When a workflow job targets a GitHub environment, that environment name is embedded in the OIDC subject claim. Your IAM trust policy can require that claim to be present, so the production IAM role literally cannot be assumed by any job that is not running in the production environment. This means even if someone crafts a workflow on a feature branch that somehow passes all your branch protection rules, the trust policy condition will reject the role assumption because the subject claim will not contain the environment name. Pair this with GitHub's required reviewers on the production environment, and you have multi-layer protection with no extra tooling. The OIDC pattern you have learned is not specific to S3. Once the configure AWS credentials action completes, the temporary credentials are available to any tool that reads standard AWS environment variables, which means the entire AWS CLI, every AWS SDK, and purpose-built GitHub actions for specific services. Deploying a new Docker image to ECR follows the same pattern: authenticate with OIDC, run the ECR login action, push the image. Updating a Lambda function, registering a new ECS task definition, deploying a CloudFormation stack, all of it flows through the same single configure AWS credentials step. The only thing that changes between deployments is the IAM role and its attached permission policies. One pattern, the entire AWS ecosystem. OIDC failures tend to cluster around a handful of root causes, and knowing them saves hours of debugging. The most common is a missing ID token write permission. The error message is clear but easy to miss in lone log output. The second is an audience mismatch. The value sts.amazonaws.com must appear in both the IAM identity provider configuration and the workflow, and any deviation causes a rejection. The third category is trust policy conditions that do not match the actual subject claim, often a capitalization difference in the organization name or a repository name that was renamed after the policy was written. The verification step using AWS STS get caller identity is invaluable. If it succeeds and prints the assumed role ARN, every subsequent AWS command in the job will work correctly. If it fails, the output from STS tells you exactly which condition was rejected. Before moving on, let us confirm the one permission that makes OIDC possible. Without it, the runner cannot request a token from GitHub's OIDC endpoint, and the entire authentication flow fails before it ever reaches AWS. Think about what the configure AWS credentials action needs to do in its first step. It must call an internal GitHub API to obtain a signed JWT on behalf of the current workflow run. That capability is gated by a specific permission that must be explicitly granted. Select the answer that enables this capability, and consider why the other options relate to entirely different aspects of the workflow. Repository content access, package registry access, and secret management are all separate permission domains in GitHub Actions.